Hi, everyone. It's a great pleasure to present the keynote speaker of the wonderful session 14 that will take place this afternoon in room Sydney. So I would like, on behalf of my co-conveners, Laurie Boita and Harold Kunzman, who could not be here today and apologizes, he's somewhere in Namibia. I would like to thank Céline Duwig for accepting our invitation. Now, you might be thinking who she is and why have we invited her. Céline Duwig is a research director at the French National Institute for Sustainable Development, known as IRD, IRD in French. She also is the co-head of one of the scientific departments, whose acronym is DISCO, but it has nothing to do with dancing. It stands for Internal and Surface Dynamics of Continents. But we have invited her first and foremost because of her research. She is a soil physicist, and she has focused her research on the study of fluxes and reactive transport in soils. She started by looking at nitrates during her PhD under Michel Vauquelin, where she worked in New Caledonia, and then she moved to Mexico, where she kind of started working on other contaminants, pesticides, and she's focused her recent research on emerging pollutants, fate, and impact, mostly working on the Bolivian Altiplano, so mountainous high catchments. And without much ado, I will leave the floor to her.
Thank you, Nane. It was a very nice introduction. And I would like to thank you, Laurie and Isabelle, to invite me today. It's a great pleasure. So I try to answer to the question, challenges in understanding the critical zone processes in subtropical and tropical zone. The challenge was for me. And so I'm going to illustrate my talk with some non-exhaustive example from OZCAR observatories under these zones, and IRD joint laboratories, which are also long-term, less long-term, but long-term research studies. So you all know these figures, and I always wanted to add lots of stuff on it. So I don't know how to drive, I don't know how to use ChatGPT, so I've put a big city, then I put desert, and I put some palm trees or rainforest. But let's go to my talk. So first I'm going to tell you the importance of tropical and subtropical regions, and then the challenges and the example-specific research addressed by the different sites, and some ideas to move forward. So what are subtropical and tropical zones? It's completely variable in climate. So we have tropical wet climate with rainfall all the time, the temperature that's not moving so much, dry climate as well. So like monsoon, we already talked about monsoon climate with or rainy season, and we have very different type of soil, deep weathered, very weathered soils like here. Here I showed you a photo of my study in New Caledonia. So I studied very shallow soil lying on top of coral rock. We have also very strong anthropogenic pressures here with the city of La Paz El Alto, where I work. So sometimes non-regulated urban extension. And here you see waste in a river in the Titicaca Lake. So these are all these challenges we have to face as well when we work on this environment. why it is important to study tropical and subtropical environment for the global understanding of the critical zone. These zones are important they play an important role for climate change. There is a two-way processes between what happened in this region and the regional and global climate, and these feedbacks are threatened. They held 80% of the world biodiversity. They provide tropical rainforests provide natural resources. By 2050, 2/3 of the world's children will live in the tropics and subtropics. And these are also populations that are very vulnerable. We know that they are usually countries with low income. And in tropical and subtropical zone, the population lives, about 70% of the population lives in urban zone. And we have about half of the world population in this zone. I'm going now to the challenges associated to the studies of this tropical and subtropical zone. I don't know where I got this map, I forgot, but Nurit had the same about when she presented the lack of study in the desert zone. So we have most of the critical zone studies in the Western countries, and with really few in South America, Africa, and some in Southeast Asia. But you can see the density is really not the same. I took this picture from Tarasova in 2024, where she showed the limited studies in hydrology, the limited number of studies in hydrology. Temperate climates, they represent 10% of land surface, but 25% of the studies, whereas the tropical area, 16% of land surface and 5% of studies, and semi-arid, 42% of land surface and 16% of studies. And here you see the number of articles in hydrology towards the gross domestic products, and you see that it's quite linear, increasing. So here you have the wealthy countries. Another example of limited studies here for micropollutants from Young et al. In 22. They review case studies published between 2010 and 2022 for micropollutants with a risk quotient above 1. I'm going to talk about later what is a risk quotient. So micropollutants with highest priority levels, and case studies that are targeting at least 10 emerging contaminants. Here you have the contaminants, medicaments, pesticides, and industrial chemicals, so like PFAS, organophosphate, etc. And it's clear it's nearly always in Europe and China and South Korea. So nearly no studies in the tropic and subtropic. Another challenge is that coming from that most of the studies are focusing in some, like here for global carbon emission, in some basin, like Congo Basin and Amazon Basin. And it represents a biais for the understanding of the tropics. So we know that tropical rivers are responsible for about 57% of the global carbon emission, but most of the studies are based on this enormous river, and they don't consider different environmental settings. And I think Clément Duvert and his colleagues are going to publish soon a study about that. Other challenges are remote access and harsh environment. Here you have flooding in Costa Rica, and a student, Morales, 24, a student from Guillaume Nord. She studied the floods, and you see that the river went up from 0.1 to 1.6 meter in 16 minutes. That means that we have also to develop different instruments that can support this extreme flooding. Here, a picture of extremely contaminated water. We have pH 3. So what about the instruments that we can use in this harsh environment? Here you have a meteo station in Nepal, in one of the sites of Glacioclim, one of the OZCAR observatory, and in Sahel, where you have here high altitude, very cold, and Sahel very remote and very dry. So challenges for the instruments, challenges also for modeling, because the processes are more extreme. We already talked about extreme processes yesterday. Now I'm going to go to the different examples. So I must say these examples are more water related than other processes because of my research. And they are what I tried. Of course, I cannot summarize in 2 slides. I've got 2 slides for each site. I cannot summarize 30 years for some sites of research, and I don't know, many hundreds of scientists working on these sites. So I've taken some examples that are quite impactant for the society. So the map, I put the different sites I've focused on the IPCC, the last IPCC map. And what I would like to show you also is that also, for example, we are working in sometimes the same climate zone. We have really different processes. So some sites in South America, in West Africa, and in Southeast Asia. First, I'm going to start with M-Tropics. They have one site in Laos, Republic of Laos, in Waipano, where I would like to tell you the impact of land use change on health in this area. So in 20 years, they had a drastic land use change with an increase of tech production. You can see that here. From 2% of the land to 35% of the land surface. So there's a huge increase of tech and a decrease of forest and fallow. And this led to increase of surface land flow, erosion. This is studied by the M-Tropics scientists. And what they could see is there is an incidence of diarrhea because of dissemination of focal contamination. What we can see is that there is a first peak here at the beginning of the raining season because of dissemination of fecal contamination by rain, runoff and erosion. But there's also a second peak here at the end of the dry season, because the explanation could be the decrease of groundwater. So they have less water accessible, and people are going to use water from rivers. So here, a very important example of how land use can affect health population. Then I go to Vietnam, Ho Chi Minh. So it's joint laboratory called, I don't remember, but you have here the acronym, and it's about water and water quality and water surface. So here I want to show the impact of megacity on the water quality. What I forgot to say you, every site I've got a summary of the main variables, so population, rainfall, average temperature. We have here this really big flow rate because the Saigon River is between 22 and 84 cubic meter per second, and the Dong Nai River, which is here, flow rate between 32 and 200 square meter per second. Cubic meter per second, pardon. We have 40 million inhabitants in Ho Chi Minh, and Saigon River received 80% of the total volume of domestic wastewater and 30% of the total volume of industrial water. Here, colleague of EG and her student, Caracciolo et al. 2024, published a paper about they targeted 219 contaminants, emerging contaminants, and 82 were quantified above the city center, in the city center, and below towards the estuary. And what we see that the city center, that's the total concentration of the different contaminants you can see here, so antibiotic, pesticides, and other contaminants. And so the big impact of the city center, which is a main hotspot of contamination, but an attenuation with dilution is observed after the affluent with the confluence with the Dong Nai River. But we still find some concentration in the estuary, so there's a transfer to the coastal environment. Now I'm going to my project, which is in Bolivia, in the Altiplano. So we are at 4,000 meter altitude, at watershed about 2,500 square kilometers, and with 1 million inhabitants living in the city of El Alto. The same colleague did also analysis of about the same contaminants in Ho Chi Minh, and here I'm focusing on sulfamethoxazole, which is an antibiotics, one of the transformation product, acetyl sulfamethoxazole and trimethoprim. These three are in the EU watch list. That means they have a high risk for health and ecosystem. The same as before, we've followed the river from the Cordillera to the Titicaca Lake, which is here. And what we found is that the urban area is mainly contaminated, is hugely contaminated. We are here at 5,000 nanogram per liter, and with a decrease after confluence of a non-contaminated river, but we still have some products in the Titicaca Lake. And here we calculated a risk quotient, which is the measured environment concentration over the lowest observed non-effect concentration, here calculated for the antibiotic resistant development. And we see that for trimethoprim, we are nearly all the sites are nearly always at high risk. So high risk to develop antimicrobial resistance due to the presence of trimethoprim. So these are amongst the oldest antibiotics used all over the world. So we have the same in France as well. But the difference, what you can see is that less water treatment plants, and also very small, very small flow rate. I'm going here on this glacier. So talking about glacioclim, which is one of the OZCAR observatory on tropical glacier. And why it's important to study tropical glacier? They have a different functioning because they have low annual thermal amplitude and high precipitation seasonality. The melting occurs all over the year, and they have a concomitance between maximum melting at low altitude and maximum accumulation at high altitude. What the impacts, so we all know that the tropical glaciers are decreasing. What is the impact on hydrology? So in these countries, there is no seasonal snow cover. Then the glaciers are the only reservoir of solid water. Melting water in this glacier near La Paz contributes to up to 30% of the water availability for the city. And the peak of the glacier contribution has already passed. And this is also right for nearly all the tropical glaciers. So there's the increasing risk of low flow during half of the year. Then stakeholder has to know how to manage, think how to manage and anticipate the decline of glacier contribution for social human activities, and especially for water, drinking water and hydropower. I'm going to Amazon Basin, where we have the OZCAR Observatory IBAM. They have 70 stations all over Amazonia. And what I wanted to tell you is a study of Calais et al. In 2004, where they show that since 1902, 4 out of 5 largest floods in the Amazon happens in the 15 last year, but also we have a decrease. We have low charge discharge that are decreasing. So the extreme in floods and in low water discharge are really increasing in the last few decades. I'm going quicker. And the last site is the Amakach Observatory, so part of OZCAR as well. They are studying the link between climate, ecology, and hydrology. And they have different sites to study all the different climates and soil and vegetation environment in Niger, Mali, Benin, and some sites in Senegal. What is important to say that, for example, in Niger now, we have such extreme temperature that, for example, in May, they have about 35 degrees mean temperature, which render the agriculture, which is non-mechanized, very, very difficult, and also the life in general. And what they found out with the study of Chanio is that we are entering now in a new trajectory for hydroclimatic. Here you have the annual precipitation anomaly. So now what it is said is that it never rains, it pours. The intensity is really increasing because of the increase of mean daily rainfall. And this intensification is due to aerosol and greenhouse gases. Some idea to move forward, but we already talked a lot about that in these 3 days. We need more data. We can do modeling, data assimilation, data structure, but we need more data. So this is an invitation to work with all these nice people. We need to, this work that we all do in these sites, they help structuring critical zone networks in the tropic and subtropics. So we need to reinforce capacity buildings, but also that they are able also to manage their own critical zone networks. We have new technology, we already talked about that, Terraforma for new instruments, low-tech, low-cost, remote sensing, but this we need data. Modeling, one question is also how to have nice model that end users can use. And also we need equitable collaboration, especially for data. We need to build data infrastructure that can hold data in this country. I think Isabel is going to talk about that in her poster, but also how all these critical zone observatories in the tropics are very close to territories. So they are answering social questions. So we need also to be able to pass more the results to the stakeholders and the society. And I just wanted to go quick. One sentence I've copied from the Livre Blanc, from Blanc et al. From the Centre de Politique de la Terre, that we need to include more the socio-economic relationship and to determine the flow that we are studying, as water and biochemical flow, for example. Thank you very much.